Hello and welcome to PreCalc Lesson 113. Today we're going to learn synthetic division. Now, what is synthetic division? You guys remember long division, don't you? The suffering, the pain, right? We would divide something like x cubed minus 4x squared plus 13 by x minus 3, and then you would suffer, right? You would suffer painfully. It seems like the theme of our week, I'll start doing this long division problem. Remember to not leave out the 0x. I feel like the theme of this week is easy tricks to do hard things that took forever last year, and the year before that, and the year before that. Yesterday we studied, or 2 days ago we studied, what did we study? Binomial theorem, finding those coefficients easily. Today we're replacing this long division. It's a good week. So, again, we go back to that thought process of sometimes we have to learn the difficult way so we can understand the easy way. And that cannot be more true here. Now, what I'm about to teach you is an easy trick to do this division, but also it opens up a number of doors, and we'll see one of them in today's lesson. So, how did we do this before? I'm just going to run through it quickly. We divided x cubed by x, that was x squared. Then we multiply these. X squared times x is x cubed. X squared times negative 3 is negative 3x squared. Change the sign in a different color. If you're still fighting me on that, you have lost the fight. Well, you don't have to do it anymore because this is gone. So, bring this down, we get x squared plus 0x. X squared divided by x is x. X times x is x squared. X times negative 3 is negative 3x. There we go. Change the sign in a different color. So, x squareds go away, we end up with 3x plus 13. 3x divided by x is 3. 3 times x is 3x. 3 times negative 3 is minus 9. Change the sign. And you get 21. So I could put remainder 21 there. Or whatever I desire. I could do 21 divided by x minus 3. Now, a couple of things to note. Number one, and this is cool, and we really didn't talk about this. When you divide, your remainder is actually really important. The remainder after division is actually the value of the function at your x value. What is my x value? It's a little tricky to see here, but it's actually 3, right? Because 3 minus 3 would be 0. So f of 3 is 21. So if you were to plug in that top part and plug in 3, you would have 27 minus 36 plus 13. I don't buy that. Is that true? Now I want to plug it into my calculator to find out. Again, a cool party trick. Minus 4 times 9 plus 13. Well, that didn't work. Which means I probably messed up. Ah! That makes me sad. Alright, well, we used an example from the book, so I can tell if I was right. And I was wrong. Where did I mess up? That's why I love this method, right? Negative 4 plus 3 is negative x squared. So, I gotta go back and fix all of this. This is why we're learning a different way. Because this way is very easy to make an error. So, if I threw you off much earlier in this lesson, I'm sorry, it's my fault. So, I'm going to subtract x, that gives me negative x squared plus 3x, changing the sign for the second time. 3x plus 13. 3x divided by x is 3. So we have 3x minus 9. Teacher tip for you. Always use the examples in the book, so if you mess up, you can check where you messed up. 13 minus 9 is 4, which is the correct answer. So, now that I fixed that, and I'm going to teach you a new way, so we really don't even care about this, I am telling you that the value of the function at 3, right, because if I plugged in 3 here, I would have 0. 3 minus 3 is 0, so x is 3. The value of my function at 3 is 4. Now this should be like mind-blowing. How can we divide and figure out the value of the function? Well, it works. Because if you're going to divide a 0 out, yeah, it's kind of a mess. Anyways, you get a 4. It's a little bit complicated. It's called the remainder theorem. It has to do with the fact that you're going to multiply both sides by x minus 3 since you're trying to find the value of the function. And should I just show you? I'll just show you. So if f of x is x cubed minus 4x squared plus 13, and I divide that by, or I want to plug in 3, I'm losing it. I have no reason why it works. Yeah, this is just a fun lesson today. Belinda's clueless, everything's going wrong. That's great. So, here, if I divide this by x minus 3, what I'm effectively doing is, if I divide on both sides, is that I'm going to get this division here, right? Let's ignore the left side right now, because I know I want f of 3, which means this is bad, right? 3 minus 3 is a no-no. But let's leave it as x. When I divide this out, I get x squared minus x plus 3 plus 4 over x minus 3. Okay, but if I multiply both sides by x minus 3, all of this is multiplied by x minus 3, which makes this 0. If I multiply this by x minus 3, those cancel and I'm left with 4. So the value of my function after this division mess is 4. It has to do with the way we write the remainder. I did know that. And none of this is a lesson. How long did it take me to get there? 7 minutes. Sorry, guys. So here's today's lesson. Today's lesson is using synthetic division. So suppose I wanted to recreate this problem using the synthetic division method. Here's what I'm going to do. I'm going to have a little backwards L box thing over there. That's going to be my x value. So if I'm dividing by x minus 3, we already talked about the fact that the x value that I'm talking about is 3. Okay? It's a little confusing, I know, but if you were to plug in our numbers to make this 0, you would have to plug in 3. So x is 3. So my x value goes there. Then all my coefficients go up here. So I took my x value from the bottom, my coefficients go on top. What are my coefficients? They're the numbers in front of each power. So the number in front of x cubed is 1. The number in front of x squared is negative 4. The number in front of x is 0. The number in front of x to the 0 is 13. And here's the process. Pay attention closely. First step, bring down the first number. Okay? I'll write it in purple, just for fun. Step 1, bring down first number. So, I'm going to bring down the 1. Then, my next step is that I'm going to multiply 3 times 1. So multiply whatever number is in the box by the number on the bottom. And that goes here. You do not have to change the sign or do any of that. So just bring down the number, multiply, see what you get. Then you're going to add or subtract vertically. I'm going to say add because that is the correct mathematical term, even if we have negative numbers. So negative 4 plus 3 is negative 1. Then we repeat the process. 3 times negative 1 is negative 3. 0 minus 3 is negative 3. 3 times negative 3 is negative 9. 13 minus 9 is 4. So my answer is, and we're not surprised, we started with an x cubed. If we divide by x, we're going to get 1x squared minus x minus 3, remainder 4. How do you know that it's x squared? Well, you have x cubed divided by x, so you know your first term is going to be an x squared. But But this is so much easier. There's no changing the sign. There's no messiness. There's no pulling numbers down than that. Okay? And we got the same result. So we could still use synthetic division to determine the remainder after division. And it's a little bit easier to see what the number is, that 3 that we're dividing by. So let's try another one. We are going to divide. Thanks for bearing with me on all that stumbling today. 2x to the 4th plus x squared plus 2x minus 1 over x plus 3. So, first step, I'm going to write my little box over here and figure out what x value makes this 0. Okay? We're doing that because that's the x we're actually evaluating at. So, the x value that makes this 0 is negative 3. You have to go backwards. Then, I'm going to write these coefficients. So, I have 2. My x cubed is 0. I have 1x squared. I have 2x minus 1. Okay, what's the first step? Bring down the first number. Then multiply. 3 times negative 3 times 2 is negative 6. Add. Multiply. Add. I have to multiply 19 times 3. Why would you do that to me? Negative 57. Again, using the examples in the book. Good thing. That's a pro teacher tip. Negative 3 times negative 55, 165. So this is negative 164. Pop. So what's my answer? Again, I multiplied, put it there, added. Multiply, put it there, added. Multiply, put it there, added. Multiply, put it there, added. And that gives you the answer. But you still need your x's back. So remember, x to the 4th divided by x is going to give you 1 power lower. So it's going to be x cubed, x squared. Put in the plus signs as you need them. And then your last term is the remainder. So that's your result of long division. Now, there is one more chunk. I hope you love this. I hope this was great for you. There's one more chunk in this lesson. They're going to ask you about zeros and roots. A zero is used with a polynomial, and a root is used with an equation. So, if you have like y equals 2x to the 4th plus x squared plus 2x minus 1, then you would have a root. If you have just that with no y equals, you would find the 0. Those are two terms to basically mean the same thing. What x value can you plug in to make that 0? And so they're going to ask questions like this. Use synthetic division to see if, so we're asking, is negative 2 a 0 of x to the 4th minus 2x cubed plus 5x minus 10? How do I do that? Well, we're going to use synthetic division. You could always just plug in negative 2 and see if you get 0. But we want you to practice the skill because you can use this on much bigger and uglier polynomials. So, negative 2 goes into the box. Notice that I use the number because that's my x value already. Here, I define my x value because they didn't give me x. Okay? Then, I'm going to write the coefficients. 1, negative 2. I'm missing the x squared, 5, and negative 10. What's the process? Bring down the first number. Multiply negative 2 times 1. Add. Multiply negative 2 times negative 4. Add. Multiply negative 2 times 8. Add. Multiply negative 2 times 11. Add. Now, what does this tell us? This tells us at negative 2, the value of my function is 12. Is that a 0? No. How would I know if it was a 0? That number would be 0. So this is not a 0. Okay? Surprisingly enough, your book actually doesn't give us an example where it is a 0. So, zeros and roots, pretty much the same thing. You're trying to figure out, does this function equal 0? If it says use synthetic division, you have to do it. And that, my friends, is problem set 113.